Greetings to the respected faculty. I am Lasya Mandapati from CSC AI&ML B section. My roll number is 24951A6686, and today I'll be presenting on the topic to authenticity and beyond, building safe and fair generative AI upon the three pillars of provenance as a part of the course Web Systems Engineering. Generative AI is transforming the internet by enabling automated creation of text, images, audio, and video at an unprecedented scale. However, this rapid advancement introduces serious concerns about the authenticity, trust, and fairness. When AI generated content becomes indistinguishable from human content, users lose the ability to verify what is real. This presentation explores how provenance, the ability to track the origin and life cycle of digital content, forms a foundation for building safe and fair generative AI systems. Provenance is not just a policy idea, it is a web engineering challenge involving system architecture, metadata standards, and platform design. Generative AI is now embedded into social media, search engines, productivity tools, and content platforms. While these tools increase efficiency, they also enable misinformation, deepfakes, and large scale manipulation. The internet was not originally designed to handle synthetic content at this scale. Traditional web verification systems focus on identity and encryption, not content authenticity. This gap creates a trust crisis. Users cannot easily determine where content comes from or whether it has been altered. Provenance systems address this by embedding traceable information directly into digital artifacts, creating a chain of custody for AI generated material. From a web systems perspective, provenance becomes part of infrastructure similar to security protocols like HTTPS. What is generative AI? Generative AI refers to models capable of creating new content instead of simply analyzing data. These systems include large language models, image synthesis networks, and multimodal AI systems. They operate by learning patterns from massive datasets and generating outputs that mimic human creativity. This makes them powerful tools for productivity and innovation. However, generative AI also amplifies risks. Fake news, impersonation, and synthetic data can spread faster than verification systems can react. This dual nature makes generative AI both transformative and dangerous. Therefore, web systems must integrate safeguards that ensure accountability without limiting innovation. Authenticity is a central challenge in the age of generative AI. When content can be generated instantly and at scale, traditional signals of credibility break down. Deepfakes, AI written articles, and synthetic voices can be used for fraud, political manipulation, and social engineering. Even legitimate AI generated content becomes suspect because users cannot distinguish it from malicious fabrications. This erosion of trust threatens the reliability of digital communication. Without without authenticity mechanisms, the web risks become an environment the web risks becoming an environment where truth is indistinguishable from fabrication. Provenance systems aim to restore trust by making original information visible and verifiable. Provenance provides a record of how digital content was created, modified, and distributed. It acts like a digital audit trail. For generative AI, provenance ensures that every piece of content carries information about its source. This allows platforms and users to evaluate credibility rather than blindly trusting content. From an engineering perspective, provenance requires metadata standards, secure storage, and tamper resistant verification. It must integrate seamlessly into web workflows without disrupting user experience. Provenance is therefore both a technical and ethical requirement for modern web systems. Provenance in generative AI is structured around three pillars: data provenance, provenance, and output provenance. Data provenance tracks the origin of training data. Model provenance records how AI systems are built. Output provenance labels generated content. Together, these pillars form a lifecycle tracking system that ensures transparency at every stage of AI development and deployment. This layered structure allows accountability to exist not just at the content level but throughout the AI pipeline. Pillar 1, Data Provenance. Data provenance focuses on the source and quality of training datasets. AI systems inherit biases and errors from their data. Without transparency, harmful patterns remain hidden. Tracking dataset origin ensures ethical data collection and legal compliance. It allows auditors to examine whether data was obtained responsibly and whether it represents diverse populations. Pillar 2, Model Provenance. Model provenance records how AI systems are designed and trained. It includes architecture details, parameter updates, training conditions, and deployment history. This documentation allows developers to reproduce results and audit decisions. If harmful outputs appear, investigators can trace them back to specific model changes. Pillar 3, Output Provenance. Output provenance focuses on labeling and verifying AI generated Each content. Each output carries metadata that identifies as machine generated. This can be implemented using watermarking, cryptographic signatures, or secure metadata embedding. Platforms can automatically detect manipulated content. Output provenance gives users the power to recognize synthetic media and evaluate credibility. Web platforms integrate provenance into APIs, browsers, and content pipelines. Trust indicators can show whether content is verified or AI generated. This creates an ecosystem where authenticity becomes visible infrastructure. Provenance transforms the web from anonymous content distribution into accountable publishing. Provenance plays a crucial role in improving safety across web platforms that rely on generative AI. In today's digital environment, harmful content such as misinformation, impersonation, and deepfakes spread extremely quickly. Traditional moderation systems often react after damage has already occurred. Provenance shifts safety from reactive moderation to proactive prevention. When every piece of AI generated content carries verifiable origin information, platforms can immediately identify suspicious sources. This makes it easier to trace coordinated misinformation campaigns or detect automated content farms. Instead of guessing who created a piece of content, systems can rely on cryptographic or metadata based verification. Fairness in generative AI depends on transparency. Without knowing where data and models come from, it is impossible to evaluate whether an AI system is unbiased or biased or discriminatory. Provenance provides the traceability needed to audit ethical behavior. Data provenance reveals whether training data sets include diverse representation. Model provenance shows how algorithms evolve over time. These records allow engineers and regulators to examine whether unfair patterns are introduced at any stage. This transparency enables measurable accountability. Ethical AI moves from abstract guidelines to an enforceable system design. Organization, Organizations can implement automated fairness audits using provenance metadata. If bias appears, the system can identify exactly where it originated. Despite its benefits, implementing provenance at web scale is not simple. One major challenge is performance overhead. Recording metadata for every piece of content requires storage, computation, and bandwidth. Systems must balance transparency with efficiency. Standardization is another obstacle. Provenance only works if platforms agree on shared formats and verification protocols. Without interoperability, provenance systems become fragmented and ineffective. Privacy concerns also arise. Tracking origin information must not expose personal identities or sensitive data. Engineers must design systems that preserve anonymity while maintaining accountability. Finally, adoption requires global cooperation. Generative AI operates across borders, so provenance standards must work internationally. These challenges show that provenance is not just a technical term, it is also a governance and infrastructure challenge. The future of generative AI depends on provenance by design systems. Instead of adding verification later, provenance mechanisms will be built directly into AI models and web architectures from the beginning. Standardized frameworks will emerge, similar to how HTTPS became universal for web security. Users may see authenticity indicators in browsers that signal whether content is verified or AI generated. Regulation will likely require provenance for high risk applications such as journalism, education, and political communication. Collaboration between AI developers, web platforms, and governments will shape global standards. Technologically, future systems may integrate cryptographic watermarking, secure metadata chains, and decentralized verification networks. These innovations will create a web environment where authenticity is visible, measurable, and enforceable. Thank you for your attention. This presentation explored how provenance can build safer and fairer generative AI systems within modern web infrastructure. As AI continues to transform how information is created and shared, trust becomes the most valuable resource on the internet. Provenance provides the tools to protect that trust by embedding accountability directly into digital systems. I hope this discussion showed that authenticity is not just a social issue, it's an engineering challenge that requires thoughtful system design. Thank you.